All right, guys. Hopefully, short one today. And then there's an assignment that you can get working on as soon as we're done talking here. So I'll keep this really sort of quick because there's only a few things to talk about in assessing normality, which is the last thing. Essentially, everything we're doing is based around a normal distribution. So when we look at a set of data, we want to know if it's normal so that we can do things like normal CDF. So how do we tell, right? How do we know? So let's take a set of data, for example, and figure out how we can say if it's normal or not. So one is to make a graph of it, right? And dot plot, stem plot, histogram, but of course that takes a while to do. The other thing you can do also is figure out if it matches up with the 68, 95, 99.7 rule. So here's what we mean by that. So essentially, if I know, let's just take this distribution here, it's a stem and leaf plot. It looks normal. So shape-wise, if I had this graph in front of me, I'd be like, you know what, this is pretty good. But even if I didn't have the graph in front of me and I just had this sort of data sitting here, maybe I run a one variable stat on it and I have these basic statistics off to the side about the mean and the standard deviation. And really with just the mean and the standard deviation alone, and of course the data set, you can, of course, figure out if something is normal to see if it fits that rule. So down here, I created a number line. And this number line in here, let's see here, 15.83 is the mean. I'm just going to label that really quickly so that we can keep track of what all of this means. And then, there it is right there, 15.825, but I rounded it to 83. No big deal. And then where's our standard deviation? There we go, about 1.217. So about 1.22. So what I did is I just went ahead and I added 1.22 to each of these. So that way we were working our way out standard deviations at a time. So quickly, we can see here that, okay, between here and here, this is one standard deviation within the mean, we should see 68% of the data. Now, is that actually the case? Now, again, we'd have to refer back up to our data, but since we have this stem and leaf plot sitting right here, let's just confirm that it is normal by looking at the number of points that are between 14.61, so they're going to be greater than 14.61, but less than 17.05. So I'm going to highlight them because I think 14.7 is going to be our first starting spot. 14.6 is lower than 14.61, right? And then up to, we can go to here. Oops, didn't mean to highlight that 17. So there we go. All right. So if we count those, we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, and 24. So we have 24. Let me jot this down here. 24 out of a total of, I just went back up to my stats up there. Apparently there's 36 in here. And if we take 24 divided by 36, we end up with, well, 66.6%, which is pretty close to 68. So yeah, that, at least within one standard deviation, it seems to check out. Let's check two standard deviations. We know in this case there should be 95% to fall within two. So we're going to extend that out to 8.27. So we'll take our 24 and we're going to add on 1, 2, 3, 4 more on the top. So we'll add 4 there. And what can we go down to? 13.3, 3, 5, and 6. So 3 and 6, 9. So it looks like we're up to 34 of the 36 data points, which if we divide that is 94%. Right, so 94%, almost exactly 95. And then, of course, for 3 standard deviations, in this particular case, everything falls within 12.17 and 19.49. This should be our 99.7%, but in this case, we end up with all 36 out of 36, which is 100%. So in terms of the 68, 95, 99.7 rule, I think that we've pretty much confirmed that this data set is in fact normal. There's no real doubt there at all. So yeah, anyway, that's one way to do it. That's a little bit complicated. Obviously, it requires quite a bit. The one variable stat, the set of data, possibly a graph just to help organize the data. And then you're like, well, if I have a graph, do I need to prove normality, or can I just like see that it looks normal, and mainly you can just see that it looks normal. So, but again, we could have done this without the graph. We would have just had to organize and pick through that data, which would have taken a while. All right, but let's look at an easier way to do this. And of course, with the easier way comes our calculator, right? So we're going to plug the data into a list is what we're going to do. And we're going to make something called a normal probability plot in our second y equals, essentially. Actually, let's jot that right here. You're going to make that in second y equals. Now, unfortunately, on this recording, I won't be able to show you all the button combinations of how to get this, but I can kind of talk you through it real quick. So if you need to pause at any point, do that and catch up with me and go back. So obviously to enter a set of data, we'll go to the stat key, all right, where we normally go into edit. And let's clear out anything in list one. So just scroll to the top and hit clear enter. And let's just enter a real simple set of data. Let's just do like, you can make up anything really, but I'm going to do like 2 1s, a 2, a 3, a 4, a 5, and maybe 2 6s or something like that. All right, so really anything, just making up some numbers. After you enter your set of data, you will go to second y equals. Okay, and you'll go into your plot one, it's on. Plot one, we've made histograms in here now. We've made box and whisker plots, but I want you to go to the last option, and I've got kind of a picture of it down here. So that's what your menu should look like right now. And then, of course, hit zoom 9. And you should get this, well, sort of some of these dots, and we're looking for something specific with these dots. And here's what we're looking for. If the graph looks linear, right, then it is a normal distribution. We can actually prove normality by just saying that this graph looks linear. If it's concave, right, it will be skewed to the left, and if it is convex, it'll be skewed to the right. And of course, oops, I've got kind of a, here, we'll scribble this blank out. It just needs to be dragged down here. Any sort of outliers that we have, will be something that's really far from that overall pattern. So there's our sort of calculator tip for the normal probability plot. We're just looking at those essentially z-scores based off that linear, that x-axis or that horizontal axis there, and seeing if these things sort of are kind of clustered and spread out evenly and everything looks good. So here's pretty much what assessing normality looks like. I've got a histogram. So we've got our 3 histograms up here. One's skewed right, symmetric, and skewed left. And then what like a corresponding box and whisker plot might look like based off that data. Obviously, you see that middle 50% kind of being pushed in one direction when things are skewed versus the symmetric one, which has the box sort of right in the middle. And then here's normal probability plots, right? And we can see in this particular case, and we'll hopefully get this sort of right here, this would be the normal one. And then this is the skewed or skew left, and this is the skew right. And you can see that just based off the fact that, this is a convex curve. It's got kind of a mound on it, whereas this is a concave curve. So it's got kind of that, I guess, cave in it. That's how I always try to remember those two, that dip in it. So there we go. Probably the number one way we're going to assess normality in this chapter is through the normal probability plot. And this is something that you're going to use all the way through chapter, I would say 11 this year when we're trying to prove normality, because we're going to rely pretty heavily on normal CDF. Either way, the assignment, you have the rest of the class to work on that. It's on the agenda, really simple section. So hopefully you have a great Spirit Day, you have a good weekend, and I will be back Monday, so we'll catch up on everything and make sure we smooth out any of the issues we had this week. But I appreciate your guys' hard work all week, and see you then.